This is important because students sometimes say, I know the chapter, so why did I not receive a high level? One of the biggest reasons students lose marks in MYP Science isn't because they don't know the science, it's because they don't understand what they are actually being assessed on. The 4 criteria aren't 4 separate hurdles. Let's take a deep dive in how it works. One of the biggest reasons students lose marks in MYP Science isn't because they don't know the science, it's because they don't understand what they are actually being assessed on. MYP Science grades students across 4 separate criteria, and that often confuses both students and parents. Hi, I'm Atul, Science faculty at Sparkl, and today I'll explain what each criterion really measures and how they are assessed, and why the same topic can test completely different skills. If your child is working hard in MYP Science, but the grades aren't matching the effort, the reasons may not be science itself. It may be the assessment criteria. A single grade can hide what a student is actually good or weak at. A student could be excellent at running an experiment, but weak at analyzing data, or great with theory, but weak at applying it to the real-world context. Criteria-based assessment exists to make strengths and gaps visible and specific. Let's take a simple example. Imagine 2 students who both scored 70% in science. Student 1 has a very strong understanding of scientific concepts, but struggles to design investigations. Student 2 performs well in practical work and data analysis, but gives weak scientific explanations. If you look only at the overall score, both students appear to be at the same level. But in reality, they need very different kinds of support. Criteria-based assessments make these differences clear. It allows teachers to say that a student is strong in scientific knowledge but needs to improve in evaluation, or that a student is confident in practical planning but needs to develop deeper explanations. This is more useful than simply telling a student to study harder. Now that we know the why behind criterion-based assessments, let's take a deep dive in how it works. Each of the 4 criteria is assessed on a scale from 0 to 8. This means that a student does not receive only one level for science, they may receive a different levels for each criterion. For example, a student may achieve 7 in Criterion A, 5 in Criterion B, or 6 in Criterion C, and probably 4 in Criterion D. This does not mean the student is generally weak or strong in science. It means that the student has developed some scientific skills more strongly than others. Teachers use criterion descriptors to decide the achievement level. These descriptors explain what the student must demonstrate at different levels. The level is usually awarded using a best fit approach. This means that the teacher looks at the student's complete response and decides which descriptor describes the work most accurately. A student does not always need to demonstrate every word of a descriptor perfectly. However, the overall quality of the work should match the level. This is also why achievement level should not be treated in exactly the same way as percentages. A level 6 does not simply mean 60%, and a level 8 does not simply mean 80%. The level represents the quality and the complexity of students' scientific thinking. Criterion A assesses whether a student understands scientific facts, concepts, and terminology, and can apply that knowledge to explain phenomena or solve problems. That means not just naming a process, but explaining why it happens and applying it to an unfamiliar scenario. Let's take an example. A student may know that the breathing rate increases during exercise. Simply stating this fact shows basic knowledge. However, explaining that muscle cells carry out respiration at a higher rate requires more oxygen and produces more carbon dioxide demonstrates deeper understanding. The student is not only recalling information, the student is connecting cause and effect. Criterion A also tests whether student can use familiar knowledge in an unfamiliar situation. For example, student may learn about photosynthesis using a normal green plant. In an assessment, they may be shown data about algae growing under different colors of light. The topic is still photosynthesis, but the context is different. The student must recognize which concept applies and then use it correctly. This is one of the main differences between memorizing science and understanding science. A student who has memorized the model answer may struggle when the wording or situation changes. A student understands the concept can adapt the knowledge to a new question. Criterion B is about scientific method itself, forming a testable question, designing fair investigation, identifying variables, and justifying the design choices. This is often where students lose marks unnecessarily because they don't clearly explain the reasoning for how they designed an experiment. For example, instead of asking, how does exercise affect the body? A stronger question would be, how does exercise duration affect the time taken for heart rate to return to normal? Students should clearly identify the independent, dependent, and controlled variables and explain why certain variables must be controlled. The method should be detailed enough to repeat and should include measurements, repeats, and safety consideration. Criterion B is not only about what the student plans to do, but also why the investigation will provide valid and reliable results. So make sure to always explicitly state your independent, dependent, and controlled variables and explain why the method chosen actually answers the question. Criterion C covers what happens after data is collected, organizing data clearly, identifying patterns or trends, and critically evaluating the investigation's reliability and validity. This examines how each limitation actually affected the results and proposes realistic improvements. This is often where strong students can distinguish themselves by evaluating thoughtfully. Criterion C begins with the way data is presented. Students should organize data clearly using suitable tables, units, graphs, and processed values such as averages. They should then identify trends, support conclusions with evidence, and explain whether the result supports the hypothesis. Evaluation should be specific. Instead of writing human error, students should identify the limitation, explain how it affected the results, and suggest a realistic improvement. Students should also understand that reliability is about consistency, while validity is about whether the investigation actually measured what it intended to measure. Criterion D looks outward, understanding how scientific knowledge and its application affect society, the environment, and everyday life. And being able to discuss this with balanced, informed perspectives, like discussing the environment or ethical implications of a scientific development and not just describing the science itself. Now, many students are often underprepared for this criteria because students focus heavily on content and skip real-world reflections. Criterion D is not simply a question about advantages and disadvantages. Students are expected to explain the relevant science, examine its impact, consider different viewpoints, and reach a rational conclusion. Criterion D may require students to consider different types of impact, such as social, environmental, economic, ethical, cultural. For example, the same scientific development may benefit one group but create problems for another. A new medical treatment may improve patient health but may be too expensive for many communities. This is why Criterion D responses should avoid one-sided statements. Students should ask, who benefits? Who may be affected negatively? What are the short-term and long-term effects? What evidence supports each viewpoint? Is the solution equally suitable in every country or community? The final judgment should come after the discussion and not before it. One of the best ways to understand criterion-based assessment is to see how one topic can be assessed in 4 different ways. Let us use the topic of exercise and heart rate. For Criterion A, a student may be asked to explain why heart rate increases during exercise. For Criterion B, the student may be asked to design an investigation into the effect of exercise duration on recovery time. For Criterion C, the student may be given heart rate data and asked to identify a trend with a conclusion and evaluate the method. For Criterion D, the student may be asked to discuss the benefits and concerns associated with wearable fitness trackers. The scientific topic is the same, but each criterion assesses a different skill. This is important because students sometimes say, I know the chapter, so why did I not receive a high level? The reason may be that knowing the chapter is only one part of the task. A student may understand heart rate but still struggles to design a fair investigation. Another student may analyze the data correctly but fails to evaluate the method in detail. This is why preparation for MYP Science cannot rely on revising notes. Student must practice the specific skill required for each criterion. The criteria-based approach in MYP Science, especially the emphasis on inquiry, evaluation, and application, directly builds the skills that DP Science subjects and internal assessments require later. In DP Science, students continue to work with unfamiliar situations, experimental data, practical investigations, and scientific applications. They are expected to write focused research questions, make justified methodological decisions, process data accurately, evaluate uncertainties, and explain the limitations of their conclusions. Students who have already developed these habits in MYP are usually better prepared for practical investigations and the internal assessment. Criterion A helps students build the scientific understanding required for DP content. Criterion B supports the planning of investigations. Criterion C develops data analysis and evaluation. Criterion D develops the ability to connect science to environmental, social, ethical, and economic issues. So the MYP criteria are not separate from future learning. They create the foundation for more advanced scientific thinking. The 4 criteria aren't 4 separate hurdles. They reflect what real scientific thinking actually looks like: understanding, designing, evaluating, and reflecting. Students who focus on strengthening each of these individually rather than only chasing an overall grade tend to do noticeably better, both in MYP and later in DP Science. Hope you found this video helpful, and for more such MYP related content, keep watching Sparkl's YouTube channel.